The output frequency of signal generator is 5 GHz. The output power is 37 dBm. We increase the output power in 1 dB to see the compression point P1 dB. Now we can see that the output power showing in the power meter is 34 dBm. Now we increase the output power in 1 dB stepping. The compression point P1 dB is reached. We change to the linear power to display. The power is 260 watts. This is a signal generator. The output frequency is 5 GHz. The output power is minus 40 dBm. The amplifier is connected with a 40 dB attenuator and microwave power meter to display. The power meter is in linear power display. Now we are showing the operating performance at 5 GHz. We increase the output power in 1 dB unit stepping. You can see that the saturation power is 510 watts now. The nominal output power is 500 watts. The maximum saturation power is 560 watts. Now we are introducing the performance of amplifier in pulse modulation mode. Firstly, we set the frequency at 5 GHz. The output power is minus 40 dBm. The displayed output value of peak power analyzer is 35 dBm without pulse modulation. Now we turn on the pulse modulation. The peak power is 33.8 dBm. The pulse width is 50 nanoseconds. The pulse period is 200 nanoseconds. The rise time is around 7 nanoseconds. The width is around 45 nanoseconds. Now we increase the output power of the signal generator by 1 dB stepping. The output power is 41 dBm now. The output power is 50 dBm now. The rise time is maintained at 5 to 6 nanoseconds. The width is around 44 nanoseconds. Now the 54 dBm is reached in P1 dB. The rise time and width is not changed much. We increase the output power to reach the saturation power. The output power is 57 dBm now. The rise time and width are maintained well. If the pulse width is wider and the period is longer, there is no problem as well. Firstly, we set the frequency at 5 GHz and the output power at minus 40 dBm. The pulse width is 30 nanoseconds. The pulse period is 200 nanoseconds. As you can see, the 33 dBm signal is generated after amplifying and attenuating at minus 40 dBm output power. The rise time is 6 to 7 nanoseconds. The pulse width is 24 nanoseconds. Now we increase the output power. Now we increase the output power by 1 dB stepping. We can see that The rise time is 5 nanoseconds, and the pulse width is around 24 nanoseconds at minus 40 dBm output power. We keep increasing the output power. The output power is 58 dBm. The rise time and pulse width is maintained well. Thanks for watching this video.
For more information on electronic measurement instruments, please visit the official website of China Electronics Technology Instruments Company Limited at www.ceyear.com.